Hi everyone, my name is Cassie Kozyrkov. I lead Decision Intelligence at Google. And today I'm going to talk to you about making data science useful. Before we do that though, what even is data science? I mean, if we're going to make it useful, we better discuss what it is. Is it doing statistics on a Mac, as the joke used to go? Or statistics by someone who's a little better at programming than regular statisticians? Or maybe it's whatever happens in Silicon Valley. Maybe it's AI. What is data science? I don't like any of these definitions. For me, data science is the discipline of making data useful. And I'm going to unpack that for you over this talk, but look at what I've done here. The discipline is making data useful, and the talk is making the discipline of making data useful, just for some looping for your minds there. So why would we need to even discuss this? Isn't this automatic? Shouldn't data science just be useful? And yet there's so many situations where I've had data scientists come up to me telling me that they're struggling to add value, that they're struggling to justify their place in their companies. And I've had business leaders say to me, our data scientists are useless. They just sit in a room and all they make is white papers. We don't get it. And they ask me, is data science a bubble? Maybe. We'll talk about that too. Maybe not. But I do think that we need to acknowledge something here. Data science has some problems. It has, in fact, got 3 problems. Let's see them. Problem 1, making. Problem 2, data. And problem 3, useful. Indeed. So these problems have solutions. I'm going to go through them with you one by one. And you'll find that this talk is also, it could have the subtitle of no wonder you have imposter syndrome, and what are we going to do about it? So let's dive in. The first one, the making and the makers, the people behind data science. We should all acknowledge that the data science universe is expanding really rapidly. There is so much to know about the everything of data, if that's what you care about. And once upon a time, maybe one person could have tried to master that entire discipline, the everything of data. But today, with that expansion, it's a losing battle. And yet somehow, data professionals still feel this pressure. A lot of it comes from outside, but a lot of it also comes from inside. I bet a lot of you are feeling this pressure to be the everything of data at your companies, to understand all of it. So the first thought, the first idea that I want to put out there is that it's time for us to fess up, own up to the fact that each individual of us is not going to be the everything of data. There is just too much here. And part of the reason for this is that the tools are getting better and easier. You all know what this is, right? Who here has punch card skills on your CVs and does not work for a museum? Now, doing things from first principles with punch cards for analyzing data, that would be the hardcore way to do it. That would be the hard way to do it. Or, do everything in C++, skip that R and Python, and in fact, please write your functions and comments in Latin while you're at it, because the hard way is really honorable. The reason you don't want to do that, and the reason that you are not proud of those punch card skills anymore, is that this was a means to an end. And those tools have gotten so much better that you don't need to worry about this. And that is happening throughout data science. Like last month, there was a big announcement. TensorFlow 2.0 came out of beta. What was the thing with TensorFlow? So I'm going to throw TensorFlow 1.x under the bus a little bit here, and that way also my employer, because TensorFlow came out of Google originally. TensorFlow 1.x, using it, quite frankly, who's going to agree with me here, was about as huggable as a cactus. it got things done. It's the industrial lathe of data science. You want to fit huge neural networks. It's good for that. But it's kind of not fun to use. And so if you were going to be a TensorFlow expert, that was going to be a lot of hours, a lot of practice and study, and hours that were not going to go to learning something else, because time is limited, unfortunately. Now, 2.0, that was where the community said, we are going to get serious about improving usability. And we're going to get serious about the data scientist as a user. We're going to make their life easier here. In that same way as I want you to imagine like the first microwave. It's probably held together by sort of hope and wires and sticky tape. And if you breathe on that thing, it falls apart. And it would have been hard to use because you would have had to figure out that launch sequence of that scientist programmed in their way to use this thing. It wasn't going to be friendly. And of course, an 8-year-old wouldn't be able to use it either. But now that these things are shown to be useful, now engineers go and package up microwaves that everyone can use. An 8-year-old can pick it up and heat up a bag of popcorn if they want to. And that same trend is happening in data science tools. A lot of it is difficult, not because it's intellectually difficult, not because it's about interpretation, but because the tools, quite frankly, are annoying. And they're getting better. TensorFlow 1.x, again, not sadism, that was a community discovering and pioneering an area. And of course, the tools are going to be bad at first. And as more people get into that, the user experience gets better, things get easier to do. Now, why am I mentioning all of this? Partly because that expansion is going to accelerate. There is a lot more interest from the user experience community now in the data scientist as user. And that's a trend that you should watch. That's a trend in AI and in analytics and in inference tools. If these things get better, if these things get easier, there's going to be more of them, there's going to be more space to cover. And here's the second part. Some of the stuff that you think is the core of your job, that is actually the wrangling of hard tools, may become irrelevant. If the tools get really easy, your employers shouldn't care which ones you come in knowing, because easy to use also means easy to learn. And that means that things are going to get abstracted to their core, not to how you fiddle with software, but how you think and interpret and perceive data. So as you strip away all that boilerplate and all that time spent on the chores, we're going to reveal the heart of what data science is about. And if there is no heart there for you, and if you think data science is just all about playing with R or Python for no reason but to play with R and Python, there is going to be a comeuppance in your life, possibly. So let's start realizing that human core of what we do here. So here's a data center full of data. What can we do with this data? What could we do if the tools were easy? And they will be easy, and they'll be getting easier at an accelerating rate. You can explore that data. I mean, what are you going to do with that data center? You don't even know what's there. You'd better get eyes on it and explore it, find out what's in it. You could look beyond the data that you have and try to make decisions about something that you don't know based on what you do. Or you could make automation solutions. Now, all of this is part of making data useful, all of these activities. And right now, the training programs that align best with mastery of these skills and tasks tend to fall out like this. Analytics programs tend to teach you all about handling what's in your data and exploring it. Statistics programs tend to make you experts in the inference side and looking beyond your data. And then machine learning and AI are all about automation solutions using data. And I'll beg your indulgence, please, for this session. I'm going to use the terms machine learning and AI interchangeably, not because I think that they are actually identical. I'm an ex-academic, I get it. But because industry at this point, quite frankly, does use them as synonyms, and I give up trying to correct people. Language evolves, so I think it's helpful just to acknowledge how most people are using the terms today. They're using them interchangeably. Or maybe you can think of this as my excuse to introduce to you my favorite definition of the difference between machine learning and AI. It's on the next slide. Here it comes. If it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. A little humor to wake you up there. So I'm going to use them interchangeably. And in these three areas, there are three excellences in terms of personality. So as you enter this field of making data useful, which I hope you are already doing or you're excited about potentially contributing to, don't worry about the tools. Don't think that using R makes you a statistician, or using TensorFlow makes you an AI person. I want you to see that core excellence, that core personality trait that really shines in these activities. So first off, let's look at machine learning and AI. So this is a real example done in Google, and this is about diagnosing diabetic retinopathy. The task here is to make an automation solution that works using data. And let me tell you very quickly, if you've somehow missed the what is machine learning definition, what is AI definition, and you're somehow in this audience, let me help you out. Traditional programming automates stuff by writing instructions. Machine learning and AI is all about using examples instead of instructions to make your wishes known. So instead of saying exactly how the task must be done, you say, here are a bunch of examples, you find the pattern, and out of that you're going to stitch the instructions. And if you've wondered whose job AI actually automates, it is the developer's job. But don't worry, there's plenty of work in data engineering and data science for developers, so I don't expect them to be going out of style anytime soon. It's just that the nature of their work may change. So this is all about automation. So what is the excellence here? The excellence is about performance. This is, I will make it work. That's the personality. This is the kind of person who you tell them, I bet that you couldn't make this diagnostic thing work with above 99.999% precision and recall. And they say to you, watch me. It's that kind of personality. And this is about making it work not just in prototype, but in production. This is engineering excellence. This is writing your code with the idea that it is actually going to live out there and be an automation solution. And so it has to have all those characteristics, like being easy to maintain, like being appropriate for shipping at the right scale, that it plays nicely with your other systems and so forth. So this is fundamentally an engineer, a software engineer. Next up, statistics. Statistics is all about going beyond what you know. You can think of analytics as dealing with what you know and statistics as dealing with what you don't. And so how do you get from what you do know, your sample, to what you wish you knew, your population? With assumptions. And it's not magical magic. You don't go in a cave and say some incantations. I'm a recovering statistician myself, so I can tell you this from the front lines. This is not how it works. Instead, the way you get from what you do know to what you don't is by building a bridge of assumptions. And are those assumptions true? No, of course not. They are cartoon sketches, simplifications of the world that someone uses to construct their little toy model that they're going to use for decision making. That's what this is all about. And so you have to be very rigorous and very careful to think through what these assumptions are that make the whole thing make sense. Because a statistical analysis that is done under one set of assumptions doesn't apply, isn't useful to someone who's not willing to buy into those assumptions, which come from personal taste, thinking about what's reasonable. They don't come from data. They are what you don't know. So, of course, a statistician then has to be very, very careful about those assumptions. And the statistician is the sort of person who would prefer that we come to no conclusions at all, rather than that we come to the wrong conclusion. So they really tiptoe. And they will slow things down, but their excellence is an excellence of rigor. They're going to think it all through carefully. And they will try to stop you from coming to completely unwarranted conclusions and running off a cliff, that cliff between what you know and what you don't. Keeps you careful. Now, what about analytics? Here's an example that I really, also an example of what statisticians do. Why are there pills on the screen? A classic task is, here's a new medication. Should we release it? And statistics is fundamentally the science of changing your mind. So, frequentist statisticians, they change their minds about actions. They start with the default action, like let's not release this medication, unless the data talk me out of it, unless the data make me feel ridiculous about not releasing the medication. That's kind of the framing. Whereas Bayesian statisticians will change their minds about opinions. Here's my opinion specified mathematically. Let me take some data and see how that data changes my personal subjective opinion. So this is all about changing your mind in order to take actions based on things that you don't know, that you can only infer or take looks at through the keyhole of what you do. Next up, analytics. So here's my favorite example of analytics, and this is actually from London, the London of 1854. There was a cholera outbreak in London. And back in those days, people thought that cholera was something that you would catch from polluted air. That was the idea. And then this fellow, Jon Snow, not the one from Game of Thrones, the 1854 one, decided to look at where all those cholera cases were happening. And this is the map. And then started thinking about what's interesting. Am I inspired to see anything here? And let me show you a little Google Maps location there. That is the water pump on Broad Street. And it seemed like these things were radiating around this water pump. And that led him and the medical profession to start to wonder, well, maybe this has something to do with water. Maybe it is, in fact, not transmitted by air. I also want to point out that this is not science happening here. And it is not any kind of rigorous statistical conclusion that you're going to get by ogling these data. What you're going to get is, this is what is here. Am I inspired? And if you use these same data to then think that you are doing some scientific statistical concluding based on what you've already seen, you're actually doing it wrong. When it comes to statistical inference, you have to call your shot before you take it. You have to actually test your theories on new data that was not used to inform your theories. In fact, if you think about the whole frequentist statistical inference setup, the whole thing boils down to, do these data surprise me? You can't really reason in those terms if you've already seen the data and you've picked how to ask your question to be surprised or not surprised by them. That's like, my dad does this when we play cards. I'll play something, I'll play a heart, and he'll go, I knew you were going to play a heart. So at some point, I got really annoyed with his analytics, and I said to him, Dad, you're going to call it before I play the card, and then I'm going to do a statistical test to see if you actually know anything about my strategy here. And the answer was no better than chance, actually. So you need to do it in a different data set than the one that you pick. So this is all about inspiration, completely different game. But what's the excellence of an analyst? This is one that people struggle to come up with. The excellence, here's my data set. The idea is find what's in it so someone can be inspired. Excellence is speed. How quickly can you discover what is here? And how quickly can you visualize just what is here, but maybe in a very large data set that's unwieldy and difficult to wrap your mind around? And so your analyst is the polar opposite in personality from your statistician who's going really slowly. But they're not making conclusions beyond the data. They're just all about what is here really quickly. And they're the polar opposite in coding style from your machine learning engineer who's trying to make a system that works. They're going to write good code. Here, good code slows you down, and it breaks the excellence of speed. And I find that great analysts get a lot of abuse from their colleagues who don't get what the analyst does. They're like, oh, you analyst, you don't know how to write code. You just sloppily prance around in your R or whatever. That's missing what is great about these people. Now, I want you to realize also that it is really hard to get all three in one person. That's the true unicorn data scientist. It can happen, but it's very rare. And I also want to point out another thing. Those who think that analytics is, baby stuff and it's not the PhD level difficult awesomeness. With machine learning and statistical inference, that is complex pursuits down a specific, narrow and deep, rabbit hole-shaped direction. If you start digging in the wrong place, though, there is no point in doing that. Sophistication for its own sake doesn't help anybody. Whereas analytics is a little bit shallow and broad, but that's how you know where to dig. And it is through analytics, through getting a feel for your data, that you know how to deploy your other experts in the first place. So if you don't have a good analytics practice, you're probably going to misuse your statisticians and machine learning folk. So those folks, instead of bullying analysts, should say thank you. Thank you for making my work useful. Thank you for first inspiring the decision makers to find where it's worth digging. And this narrow and broad sweep, if you turn your mind sideways, it's as deep. Shallow and broad is as deep and narrow as the other two. These three roles, they are all equally skilled and mathy and cool, frankly. But because they don't tend to coexist in one person, they are totally different attitudes. You're going to have to appreciate that data science is a team sport. You need different kinds of people to do it. And so allow yourselves to own which kind are you? What are you most drawn to? And don't be bullied or turned away from that path to try to follow someone else's excellence. Pursue your own excellence and appreciate the excellence in your colleagues. And now in the last 5 minutes, the other two, after this part, they go faster. The data problem. This is not an isolated incident. I've had people come up to me telling me that they have been hired to be chief data scientist in a place without data. I don't know whether to laugh or to cry. Data science doesn't make sense without data. You are at the mercy of data engineering. And data engineering, if data science is making data useful, data engineering is making it usable. You need data. And if there is no one around, no colleague, to bring you the data that you can make useful, that is going to be on you. But it is a different discipline from data science. And if you have studied data science, you have tended to work with data that's small data sets, like spreadsheets. That's like you have learned to go to the grocery store and get a pint of ice cream, and that's easy to do. But now I ask you to deliver me 20 million pints of ice cream and don't let it melt, and it must be here on Friday. That is actually sophisticated now and difficult, and you are not qualified for it. And similarly, data engineering at scale becomes a sophisticated discipline in its own right. And I want you to appreciate that data also comes from people. This business of the data never lies, it always tells the truth. Well, people make data, and it is basically a textbook for your machine or your decision makers to learn from. And like a textbook, it has human authors. I'm going to give you the Hemingway lecture in just 6 words on AI bias. Just 6 words. AI bias. Inappropriate examples never examined. Someone took a human-authored textbook, possibly authored by some prejudiced individual, and didn't bother to open it first before giving it to their student. Why would you be surprised that your student then learns what's in the textbook? So how do you avoid it? Analytics. Open the textbook. Have a look at what's inside. And make sure that your authors have diverse perspectives, but also the people checking it for appropriateness. If it's all the same kind of person checking it for appropriateness, you're not going to catch ways that it might offend other kinds of people. And that is why, in data science, diversity is not a nice to have, it's a must. And then finally, the useful. This was our taxonomy, but I give you a different one. Many, few, and none. And I once put this up and I asked people, what do you think many, few, and none stand for? And they were like, data points. And I said, well, with no data points, analytics is a little bit difficult. So instead, this is decisions that you know you want to make before you get the data. Many decisions, automation, that's machine learning. A few important decisions beyond the data, that's statistical inference. And if you have no idea what you want with this data set, the only thing you can get is inspiration, that's analytics. To get any of this done well, you need to know how you want to use the data for decision making. That's why decision makers, the people who call that shot and who frame the whole thing, are really important. And if you've been struggling to add value in your organizations, it's probably because you don't have that leadership piece. All of this has to get kicked off by the leader, unless it's pure analytics, in which case we can all open a data set and have a look. And don't go hiring the other experts if you don't know what you want with them. Always hire the analyst first, hire the decision maker, that's good for all companies. But the AI, machine learning, statistics stuff, you only need those folks when you know what you need them for, when you know what you want to do with data and how. And that vision comes from decision makers. Otherwise, you think you're building this in data science, you're actually building that. In the middle of the ocean, to the middle of the ocean, missing the front bits that make this all make sense. It's an end-to-end process that starts with analytics and decision making. So data science really needs leadership, really needs decision makers. And we need to own that you can't just expect data scientists to step up and know how to do this. They don't learn that either. I'll tell you, in stats courses, hypotheses are always made for the students. They don't come up with that themselves. They don't think about what's important for the business. That's not part of the mathematical training. So we have to start teaching the people around us who have potential for good decision making, for good leadership in this, how to be data literate. That's really important. In summary, all of it's human. We've been hiding behind equations and tools too long. It's time to see that gory human core. We think that data and data science is all about engineering. It's more about interpretation. And it's going to be more about that as those tools get better and better. So I want you to start to see that human side. And I want you to focus on the people who make data useful. Do it in reverse. Start with the useful. Then go to the data. And then do the making. Thank you very much.